Have you ever tried to truly wrap your head around how big the solar system is? We see diagrams in books all the time, with neat little circles representing the planets, all lined up in a row. But those pictures are incredibly misleading. If we were to build a model of the solar system to scale, the reality would absolutely blow your mind. Let's try it. Imagine we shrink the Earth down to the size of a single green pea, a tiny little pea you can hold between your thumb and forefinger. At this scale, how far away would the moon be? Take a guess, maybe a foot away? A few feet? Nope. At this scale, the moon would be a grain of sand orbiting our pea-sized Earth from about 7 inches away. Already, that's a bit more space than you might have pictured. Now, let's place our pea-sized Earth down and think about the Sun. How big would the Sun be, and how far away? The Sun, at this scale, would be a glowing, brilliant sphere about 5 feet in diameter. Think about that, a 5-foot ball of plasma. And where would we put it? You'd have to walk about 540 feet away from our pea-sized Earth to place it. That's almost the length of 2 football fields. Imagine standing there, holding this tiny pea, and looking at a 5-foot wide sun almost 2 football fields away. That's the real scale of our home in space. Okay, let's build out the rest of the inner solar system. We have our 5-foot sun. Mercury, a tiny seed, would be about 210 feet away from it. Venus, another pea, just like Earth, would be orbiting at around 390 feet. We've already placed our own Earth pea at 540 feet, and Mars, a slightly smaller pea, or maybe a large pinhead, would be out at a distance of about 820 feet. So, just to map out the inner rocky planets, we need a space larger than a city block. All the illustrations you've ever seen cramming them together, totally wrong. Now, for the gas giants, this is where things get truly wild. Jupiter, the king of the planets, would be a grapefruit at this scale. A grapefruit. Compare that to our little pea. And where is this grapefruit orbiting? It's half a mile away from our 5-foot sun, half a mile. You'd need binoculars to see the sun from Jupiter at this scale. Think about the immense empty space between Mars and Jupiter. It's vast. Let's keep going. Saturn, famous for its rings, would be a small orange, and it would be orbiting nearly a mile away from the sun. The rings themselves would be incredibly thin, like a sheet of paper stretching out around the orange. Then we have Uranus and Neptune, the ice giants. They would both be about the size of a large gumball or a small plum. Uranus would be almost 2 miles away from the sun, and Neptune would be a staggering 3 miles away. So, let's recap our model. We have a 5-foot sun. We walk for a few minutes to get past Mars. Then we have to walk for a very, very long time to get to grapefruit-sized Jupiter half a mile away. We keep walking, and a mile from the sun, we find orange-sized Saturn. 2 miles out, there's Gumbo Uranus. And finally, 3 miles from our starting point, we find Gumbo Neptune. Our entire solar system, with the sun as a 5-foot ball, is a model 6 miles wide. And what about Earth in this vast model? It's just a single pea lost in the expanse. But wait, we're not done. What about the dwarf planets, like Pluto? Pluto would be a speck of dust, a tiny grain, orbiting on a weird tilted path somewhere between 3 and 5 miles from our sun. And this is just the main planetary region. Beyond Neptune lies the Kuiper Belt, a massive ring of icy bodies. In our 6-mile-wide model, this belt would be a sparse donut of dust specks and sand grains stretching for miles and miles. And beyond that, the Oort cloud. This is a theoretical, gigantic spherical shell of icy comets that is thought to surround our entire solar system. How far out would it be in our model? Get ready for this. The inner edge of the Oort cloud would start about 200 miles away from our 5-foot sun, and it might extend outwards for thousands of miles. Imagine our 6-mile-wide planetary system, which already felt huge, sitting inside a bubble that is thousands of miles across. It's almost impossible to comprehend. All of that is considered part of our solar system, and the next star, Proxima Centauri, is the closest star to our sun. In our pea-sized Earth model, where the sun is a 5-foot ball, how far away would the next star be? Thousands of miles, tens of thousands. The next star, which would be another ball of fire, would be about 25,000 miles away. That's like placing one 5-foot ball in New York City and its nearest neighbor in Perth, Australia. And in between, mostly just empty, cold, dark space, with our little 6-mile-wide system of planets floating in the middle of it all. So when you look up at the night sky, remember this. The distances are not just big, they are mind-crushingly, beautifully, terrifyingly immense. The diagrams we draw are just convenient cartoons. The reality is a masterpiece of emptiness and scale. We are living on a tiny pea in a system 6 miles wide, separated from our nearest neighbor by the distance of a trip around the entire Earth. Thanks so much for watching and exploring the cosmos with me. If this blew your mind, hit that like button and subscribe for more deep dives into the universe. See you in the next one.